What's up, all you mathematicians? Happy Thursday. We are looking at surface areas again today. This time we're doing pyramids and cones. So, just again, more formulas. This chapter is all about formulas. I'll tell you what, if you write down all the formulas on a piece of paper or something, keep that handy and you'll be able to use that on the test. So, make sure you're writing down all the formulas on one sheet of paper so that you have them all right there and you're able to use them. Okay, so in case you don't remember, a pyramid is a polyhedron in which one face, that's supposed to say one face, which is the base, can be any polygon, and the other faces, which are the lateral faces, are triangles that meet at a common vertex, called the vertex of the pyramid. So it can be any base. You know, the famous pyramids in Egypt are squares, so they have a square base. But this is any pyramid can be any base as long as you've got a base and then they all go up to some common vertex. So the base is how you name it, and then all of the other ones are called lateral faces. So you've got an altitude of a pyramid goes from vertex to the base and is perpendicular, and that's going to be useful. And then I guess that's pretty much it. You got slant heights is the perpendicular height from the vertex down an edge. Yeah, and then what else we got? Got that. A regular pyramid is a pyramid whose base is a regular polygon and whose lateral faces are congruent. And again, the slant height is the length of the altitude of a lateral face of the pyramid. Okay, so let's look at that formula. Surface area of a pyramid, any regular pyramid, the surface area is the area of the base plus 1/2 the perimeter times its slant height. Okay, so we're going to apply that formula here. What is the surface area of this hexagonal pyramid rounded to the nearest whole number? Okay, so there's a couple of things we need to know. We need to know the area of the base. So again, we've got to remember that formula for the area of any regular polygon, which is area of any regular polygon. Do you remember it? 1/2 the apothem times the perimeter. Okay, so it looks like I was nice enough to give you the apothem of the hexagon and the length of one of the sides, so you should know all of the information you need. So in this case, it would be 1/2 3 square roots of 3 times the perimeter. If one side is 6 and there's 6 of them, that would be a perimeter of 36. So half of 36 is 18, and 18 times 3 is 54 square roots of 3. So there is the area of the base. We also need to know the perimeter, which we just kind of already found. It was 36. And we need to know the slant height, which is a kind of a fancy L. I don't know why. Don't ask me. Slant height, they give it us in that picture, is 9. Okay, so we've got all three things. We just plug it into the formula. Surface area is the area of the face plus 1/2 the perimeter times the slant height. Okay, so that would be 54 square roots of 3 plus 1/2 of 36 of 9. Okay, so that would be 54 square roots of 3. Half of 36 is 18. And 18 times 9, I believe, is 162. I want to check my math on that. I just kind of did it in my head. 18 times 9. Yeah, 162. Got it. Okay, they say round it to the nearest whole number. So that would be radical form. Round it to the nearest whole number. We just want to type that sucker into our calculator. 54 square roots of 3. Close that parenthesis. Plus 162. Round it to the nearest whole number. It's about 256. It's still an area, so our units are squared. It's 256 square inches. Nice. Okay, here we go. A meditation pyramid, if you're into that hippy dippy stuff, is built to the following dimensions. If they were to cover the pyramid in cloth, what is the minimum area needed rounded to the nearest whole number? Now, we have to think about this situation. We're going to cover this guy in cloth. Are we going to put cloth on the ground? Probably not. We're just covering the pyramid, right? So we're going to modify that formula. We no longer need the area of the base. We just need the 1/2 perimeter times the slant height part. So that's all the information that we need. Okay, so the perimeter is easy enough to find. It says it's 8 by 8 by 8, so 8 times 4 is 32, so my perimeter is 32. The slant height, we are not given that, but look at that right triangle in there. That's going to be helpful. We know that the altitude of that is 5. Sorry, you can't see that very well. Let me see here. So we have to think about that right triangle. If the whole length of a side of the pyramid is 8, the vertex is going to go directly to the center. The bottom of that triangle would be 4. Now we can use the Pythagorean theorem to find that slant height. So it would be 16 plus 25 equals the slant height squared. So that's going to be 41 equals the slant height squared. So the slant height is going to be equal to the square root of 41. Whatever that is, it doesn't matter. Okay, so we've got the information. Now we just type or fill it into our formula, and then we'll type it into our calculator. Okay, so I know half of 32 is 16, so I'm just going to do 16 times the square root of 41. Rounded to the nearest whole number, we need about 102 square feet of cloth to fill that pyramid. But I would probably actually buy 103 since we need 102.44. At least 103. I'd probably buy more than that because I'd probably make a mistake when cutting cloth. All right, on the back we're going to be looking at the surface areas of cones. So a cone is not a polyhedron because it's got this curved side, but it is a solid that has one base and a vertex. However, the base of a cone is a circle. So in a right cone, the altitude is perpendicular segment from the vertex to the center of the base. And that's what we're going to be looking at today. The slant height, again, is that lateral distance from vertex to the edge of the circle. And the lateral area is just the cone part, not the bottom of the cone or the top of the cone, whichever way you're looking at it. So here's the formula, much like the surface area of a pyramid or whatever, is the area of the circle plus pi r l, and that's the lateral area part. Pi times radius times slant height. And then remember, the area of a circle is pi r squared. So I really just write it as surface area of a cone is pi r squared plus pi r L. Okay, so this one asks for what is the surface area of the cone in terms of pi. So we're going to leave it in terms of pi. So I'm going to write down that formula, pi r squared plus pi r L, slant height. Okay, I think we have all the information already. We see the radius, we see the slant height. That's the only two things that we need. So we're just going to fill it in. Pi times 15 squared plus pi times 15 times 25. I know that 15 squared is 225, so that's going to be 225 pi. 15 times 25 is 375, so plus 375 pi. Adding those two together, looks like we would have 600 pi square centimeters. And then, of course, if they asked you to plug in 3.14 or use the pi button, you could do that. Here's our last example. In a lab experiment, scientists use the funnel shown below. What is the minimum amount of filter paper needed to line the funnel? So we're just going to line the funnel with paper to help protect that funnel. And so to do that, we would not need a top. So we're going to, again, adjust our formula. We don't care about the base anymore because we're not going to put paper around the circle. We're just going to cover the lateral area. So we're just looking at that pi r L part. Okay, so it looks like we don't have either of these pieces of information. I have no radius or no slant height here. But the radius is easy enough. It's half the diameter, so I know that the radius is 40. And then the slant height we can find by drawing that right triangle. So 40, 45, and then we're looking for that slant height, which is going to be the hypotenuse. So that means that 40 squared plus 45 squared is going to equal our slant height squared. So I'll just type that one in. Those are too big of numbers for me to mess with. 40 squared plus 45 squared. 3,625. I think that may be a perfect square. We'll see. Let's take the square root of it. Square root of our answer. It's not. That's too bad. So we're just going to leave it as slant height is the square root of 3625. Okay. So now we have all the information. Just fill it into the formula. Pi times radius, which is 40, times slant height, which is the square root of 3625. Okay. It doesn't tell us, so we'll do terms of pi and we'll do rounded to the nearest 2 decimal places. Okay, so let's see, 40 times the square root of 3625. Okay, that's pretty gnarly. It didn't even give us a rounding. We'll just go to the nearest whole number. 2,408 pi. And then if I were given to use 3.14 for pi, I would not use 2408 pi. I would use this decimal number and then times it by 3.14 or pi if they want the pi button. Rounded that to the nearest whole number, it would be 7562. Both of these, by the way, are square millimeters. So again, not too difficult stuff today. You just have formulas you got to apply. Let me know if you need any help on my math lab, though, and I will talk to you soon. Have a great day, guys.